The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So far we've seen things about vectors, equations of planes, motions in space, and so on. Basically, we've done geometry in space. But calculus really is about studying functions. So now we are going to actually move on to studying functions of several variables. So this new unit, what we'll do over the next 3 weeks or so, will be about functions of several variables and their derivatives. Okay? So first of all, we should try to figure out how we are going to think about functions. So remember, if you have a function of one variable, that means you have a quantity that depends on one parameter. Maybe f depends on a variable x. And for example, the function that you all know is f of x equals sine x. And the way we would represent that is using maybe by plotting the graph of a function. So the graph of a function, we plot y equals f of x. And in the case of a sine function, that looks like this. Okay. So now, let's say that we have actually a function of two variables. So that means that the value of f depends actually on two different parameters. Say, maybe the variables are x and y, or they could have any names you want. Okay, so given values of the two parameters x and y, the function will give us a number that we'll call f of xy that depends on x and y according to some formula. Okay, not very surprising so far. So for example, I can give you the function f of xy equals x squared plus y squared. And of course, as with functions of one variable, we don't need things to be defined everywhere. Sometimes there's a domain of definition. So this one is defined all the time. But if I tell you, say, f of xy equals square root of y, well, this is only defined if y is non-negative. Or if I tell you f of xy equals 1 over x plus y, well, that's only defined if x plus y is not 0, and so on. Okay. Now, so these are, mathematical examples given by explicit formulas. And of course, there's physical examples, or examples coming from real life. For example, you can look at, the temperature at a certain point on the surface of the Earth. So you use maybe longitude, latitude, that's x and y, and then you have f of xy equals the temperature at that point. Or in fact, because temperature depends also maybe on how high up you are, it depends on elevation, so it's actually a function of maybe x, y, z, and it also depends on time, so in fact maybe it's a function of t for time, x, y, z coordinates in space. So you see that real-world functions can depend on a lot of variables. So our goal will be to understand how to deal with that. Okay. So Now, you'll see very soon that actually it's already tricky enough to picture a function of two variables. So we're going to focus on the case of functions of two variables. And then we'll see that if we have more than two variables, then it's harder to plot the function. We cannot draw what the graph looks like anymore. But the tools are the same. The notion of partial derivatives, gradient vector, and so on, all the tools that we will develop work exactly the same way, no matter how many variables you have. So I'll say, for simplicity, we'll focus mostly on two, or sometimes three, variables. But it works the same in any number of variables. Okay, so the first question is, how do we visualize a function of two variables? So the first thing we can do is try to draw the graph of f. So maybe I should say f, which is a function of two variables. So the first answer will be we can try to look at its graph, and the idea is the same as with one variable, namely we look at all the possible values of the parameters x and y, and for each of them we plot a point whose height is the value of a function at these parameters. So we'll plot, let's say, z equals f of xy, and now that will become actually a surface in space. Okay, so for each value of x and y, here we have xy in the xy plane, then we'll plot the point in space at position xy and z equals f of xy. Okay, and if we take all of these points together, they will give us some surface that sits in space. Yes? Oh, a function of two variables. Shorthand. Well, let's say how to visualize a function of two variables, if you want. Okay? So how do we do that concretely? Say that I give you a formula for f. How do we try to represent it?